Today's video is on applications to difference equations, and this topic is from Z transforms. In this video, we are going to solve the difference equation using Z transforms. The equation here is y of k plus 2 minus 4 times of y of k plus 1 plus 4 times of y of k is equal to pi, and the given conditions are y at 0 is equal to 0 and y at 1 is equal to again 0. And see, in order to solve this problem, so we have to take certain conditions. That is, let Z transform of y of k is taken as capital Y of Z, and next one Z transform of y of k plus 1 is taken as Z power 1 into this is y of Z minus y naught, and next one Z transform of y of k plus 2 is equal to this is z square times of y of z minus y naught minus y1 by z. Clear? And next one, what is the equation given here? The equation is given as y of k plus 2 minus 4 times of y of k plus 1 plus 4 times of y of k is equal to pi. Now I am taking z transforms on both sides. See here, taking z transforms on both sides. So this will become, see here, so if I take z transforms on both sides, then z transform of, see here, this is z transform of y of k plus 2 minus 4 times of z transform of y of k plus 1 plus 4 times of z transform of y of k is equal to, so this is pi times of z transform of 1. So pi, as it is a constant, pi times of z transform of 1. And now see here, z transform of y of k plus 1 can be written as this is, see here, z square into y of z minus y naught minus y1 by z. Clear? Minus 4 times of z transform of y of k plus 1 can be written as z into, see here, this is z into y of z minus this is y naught plus 4 times of z transform of y of k. See here, z transform of y of k is equal to capital Y of z, capital Y of z, which is equal to, this is pi times of, see here, z of 1. Z of 1 can be written as z by, this is z minus 1. Clear? And next one, the conditions are, what are the conditions here? Y naught is equal to 0. So given y naught is equal to 0 and again y1 is equal to again 0. Now we have to substitute y1 as 0 and y naught as 0. So after substituting y naught 0 and y1 0, what remains here? So this will be z square times of y of z minus this is 4z of this is y of z, y naught is equal to 0 plus 4 times of this is y of z is equal to this is pi z by this is z minus 1. Clear? So if I take y of z common from this equation, then what remains? So y of z is equal to, see here, y of z is equal to this is z square minus 4z plus 4 is equal to this is pi z by this is z minus 1. Clear? And next one, y of z can be written as this is pi z by z minus 1 into this is z square minus 4z plus 4. And now if I send this z to other side, this will be y of z by z is equal to pi times of this is z minus 1 into this is z minus 2 whole square. Clear? I am writing this as z square minus 4z plus 4. So now after that one I have to resolve it to partial fractions. So y of z by z is equal to this is pi times of, see here, it is pi times of, this can be written as a by z minus 1 plus this is b times of b by z minus 2 power 1 plus again c by this is z minus 2 square. So I need the values of a, b and c. So for that, so I have to substitute here. So this is nothing but y of z by z is equal to, the equation here is y of z by z is equal to, this is pi times of, this is a by z minus 1 plus this is b by z minus 2 plus c by this is z minus 2 whole square. So I need the values of a, b and c. And now how to get this values? So here, in order to get the value, so this can be written as 1 by z minus 1 into, this is z minus 2 whole square is equal to, here if I take LCM here, this will be z minus 1 into here z minus 2 whole square. This is a times of. So here there is z minus 1. What remains here? Z minus 2 whole square plus b times of, here this is z minus 1 into this is z minus 2 plus this is c times of, this is z minus 1. Now if I cancel the denominators, what is the equation left? So 1 is equal to a times of, this is z minus 2 square plus b times of, this is z minus 2 into z minus 1 plus c times of, this is z minus 1. Now we need the values of a, b as well as c. Now put z is equal to 1. So if I keep z is equal to 1 and see, this will become 1 is equal to, 1 is equal to, so this will be 0 and this will be 0. So a times of, this is 1 minus 2 whole square. So 1 is equal to, this is minus 1 square and again this is plus 1. 1 is equal to a. So we got the value of a as 1. And the next thing here is put z is equal to 2. If I keep z is equal to 2 and c, then this will be 0 and this will be 0. So what remains here? So 1 is equal to c times of 2 minus 1. So 1 is equal to c and I got the value of c as 1. So, and there is no other substitution for finding the value for c. And therefore what I am going to do is, so I am comparing the quotients of the highest degree term. Highest degree term is z square. Quotients of z square on both sides. So I have to compare quotients of z square on both sides. Here there are no z square times from LHS. Therefore this is 0 and this is z square. The quotient here is a, and if you multiply we'll be getting z square and the quotient here is b. So 0 is equal to a plus b. Here the value of a is equal to 1. Therefore this is 1 plus b and therefore we got the value of b as minus 1. So after getting a, b, c values, we have to substitute here in this equation. So in this equation, if I substitute, then see what happens. So y of z by z is equal to, this is pi times of, a value here is 1, that is 1 by z minus 1. B value here is minus 1, that is minus 1 by z minus 2. And here c value is again 1, that is 1 by z minus 2, this is whole square, z minus 2 whole square. And now I am sending this z to the other side. Then this will become y of z by z. See here, y of z is equal to, this is pi times of, this is z by z minus 1 minus z by, this is z minus 2, and this time this is z by, this is z minus 2 whole square. And now the next step here is taking z inverse on both sides. On taking z inverse on, this is both sides. So this will become y of z by z is equal to, so y of z is equal to, this is pi times of, this is z by z minus 1 minus, this value is z by z minus 2 plus, and this value is z by z minus 2 whole square. Now I have to take z inverse on both sides. So this will become z inverse of this one and this is z inverse of this, and again z inverse of z by z minus 2 and z inverse of z by z minus 2 whole square. Now I have certain formulae from the special functions, that is z inverse of, so according to our formula, z inverse of z by z minus a can be written as a power n, and the next thing here is z inverse into, this is az by z minus a whole square. So for this term is can be written as n into a power n. So according to our special function, so I am applying these two formulae, and see in the next step what I am going to do is z by z minus a, z by z minus a, in place of a we have 1, and z by z minus a, in place of a we have 2, and here z minus a. So we have a as 2 and there is no 2 here. I am multiplying and dividing with 2. So therefore z inverse of y of z is equal to, this is pi times of, so this can be written as 1 power k and this can be written as 2 power k, and here I am multiplying and dividing with 2 here. Z inverse of this is 2z by z minus 2 whole square. So if I compare with this, az by z minus a whole square. So in place of a we have 2. Therefore, in place of n I am taking k, as from the question it is given as in place of n we have k. Therefore, this is pi times of 1 power k minus this is 2 power k plus half times of, what is the formula? N into a power n. So here n I am taking it as k, and in place of a we have 2 and this is power n, power k. So our final answer, z inverse of y of z is equal to, this is pi times of 1 minus 2 power k plus k times of, this is, if I send this denominator to numerator, this will be 2 power k minus 1. And this is how we have to solve, and this is also so simple if you practice, and definitely I'll explain you once again. So first of all, this is the difference equation given and we have to apply z transforms. For that, these are the conditions. We have to take z of y of k as this, z of y of k plus 1, z of y of k plus 2, and from for the given equation we have to apply z transforms on both sides, and here the conditions are y0 is equal to 1 and y1 is equal to 0. If I apply and take y of z common, so I am sending this z square minus 4z plus 4 to other side, and here is the thing, that is pi by z minus 1 into z minus 2 whole square, and I have to resolve into partial fractions, and after resolving into partial fractions I need the values of a, b and c, and after substituting a, b, c values, so I have to apply z inverse on both sides and using these two special functions formulae. So this is the final answer. This is how we have to solve. Hope you all guys understand. If you really understand, you know what to do. Please subscribe to this channel, and I'll be uploading many more videos regarding this series. Please go through them and please share with your friends. Thank you so much.